Hello everybody, my name is Chloe Fletcher. I'm a sustainability data scientist working within BBC Research and Development. My role is to use data modelling and analysis to evaluate the environmental impact of media technology and services. So in today's talk, I'll be taking you through a recent project looking at the energy footprint of BBC Radio. I've only got 10 minutes, so if you're interested in learning a little bit more, you can check out the paper we published last week towards the end of the session. So what were we trying to achieve? Our main objective was to understand how much energy was required to prepare, distribute and consume BBC Radio. So not just what the BBC is directly responsible for, but also in the consumption of our content. And then we wanted to understand how this energy may change over time. If we were to switch off certain platforms in the future, what impact could that have on the total energy? And lastly, we wanted to understand where the key hotspots are in the system. Where do we need to focus our efforts if we want to reduce our energy footprints? How did we go about this? Our research was split into two key parts. We had our baseline, so looking at energy as it stands today, and we used the reference year of 2018. And then we modelled a variety of scenarios, and we did that over a 20-year time period to understand the future dynamics. And also for radio, we've not just considered live content, we've also considered podcasts and catch-up within our scope. So just to give you a bit of context of what the BBC radio system looks like, this map here shows you the point of production all the way into the listener's ears. So we've not actually included production in our scope, but everything that happens from that point. As you can see, we offer a variety of different platforms in order to listen to radio. We have AM, which includes medium wave and long wave, FM, DAB, DTV radio services, which are available on terrestrial, cable and satellite. And also we have our internet distribution, which includes BBC Sounds, as well as content available on other platforms such as Spotify and YouTube. And as you can see in this map, we've color-coded it in where it fits within the radio chain. So we've got preparation, which includes playout, encoding and multiplexing. We've got distribution, which includes the transmitter networks, as well as the internet infrastructure. And lastly, we have consumption, which includes all the devices in which you can listen to radio. And I don't have time to go into our full methodology. However, essentially what we've done is translate this system map here into a mathematical model, which outputs energy on a monthly basis for each of the components you see within this map. So jumping straight into our baseline results, here you can see the energy use for each radio platform in 2018. At the bottom is the total of all the platforms together, which was 325 gigawatt hours. To put that into a bit more context, that's about 0.1% of UK energy use in 2018. And FM had the highest share overall at about 31% of the total energy, and AM had the lowest at 8%. And for DAB, it sat somewhere in the middle at about 20%. So consumer devices were shown to be the biggest part of the chain. They use up nearly 3/4 of the total energy within our system, which was actually a bit of a surprising result, as transmitter networks are often touted as being the high power consuming things. But actually what we see here is that the consumer devices are using a lot more energy, which actually does make sense, because even though on an individual basis they might be quite low powered, when we're scaling up to the tens of millions, actually that can really add up in terms of energy use. And when we zoom into this even further, what we see is that the three biggest components within our system are analog radio sets, DAB radio sets and television sets, which collectively make up more than 50% of the total energy. And when we zoomed in even further, what we saw is that the biggest contributor was the standby power of radio sets, as well as smart speakers. However, not all the platforms are listened to equally. As we can see here, FM and DAB have a much higher listenership than AM and DTV radio services. Therefore, perhaps a better way to compare platforms would be to look at the energy consumption per hour of listening. And when we do that, we actually see a very different picture, in that DTV radio services has got the biggest footprint at 81 watt hours per device hour, whereas DAB has the lowest at 9 watt hours per device hour. So essentially DAB uses 1/9 of the energy per hour of listening than DTV radio services, which is quite intuitive, because if you're listening to the radio on a television, you've got a screen and perhaps a set-top box associated with that. But what's also interesting is that FM uses approximately 40% more energy per hour than DAB. And that's mainly because of the higher power consumption of the FM transmitter network, and that the DAB radio is tending to have a lower standby power on those devices. So this just gives a bit of a quick summary of the results for our baseline. As I said previously, we published our paper last week, so you can read a little bit more detail about the results we got, as well as some sensitivity analysis considering how confident we are in those results as well. So moving on to our scenario results, it's probably worth me introducing what the scenarios we actually considered within the study. So we looked at 4 different indicative cases to test the modelling capability that we had. It's worth noting that these do not represent the intentions of the BBC, and they've just been used here for illustrative purposes. So we have used the business as usual case, so essentially keeping on all the platforms that we offer now for the next 20 years. And then we've looked at a digital only case, so considering if we turned off all our analogue services from 2030, what impact that would be. And we've got scenario 2 where we keep on DAB and IP and switching off analogue and DTV radio services at 2030. And lastly, we have this IP only case where we switch off all of our other platforms from 2030. And it's worth bearing in mind that we've assumed a sudden switch off at 2030 happening overnight instead of a gradual process, which would be more likely to happen in reality. So in our business as usual case, we can see that there's very little difference in the total energy over the 20-year time period. There's some dynamics within that, in that you can see that the AM and FM listenership decreases over time, as well as the IP devices consuming more energy over time. And that's just because of how we've modelled them to their natural popularity over time. And this was shown of all the scenarios we looked at to be the worst outcome. So essentially, we shouldn't just keep things as they are now. And then moving on to scenario 1, where we switch off all our analogue services, there is a slight energy reduction compared to business as usual, but in all the switch off scenarios that we considered, this was shown to have the smallest reduction overall. And this is despite there being a removal in the AM and FM infrastructure. What we see at the point of 2030 is that there's only a 0.03% drop in the energy. And that's mainly due to there being a greater uptake in DTV radio services that we've modelled, as well as a greater uptake in smart speaker use. And so we ran a bunch of different configurations of what devices people might switch to after analogue services were switched off. And what we actually saw was that if more people moved to DTV radio services, we could actually see an increase in the total energy. And if more people moved to DAB, then we could actually see a greater decrease. And then looking at this second scenario, if we were just to retain DAB and IP, we actually saw the biggest reduction of all the scenarios that we could modelled. We saw a 23% drop at 2030, which was sustained for the remaining period of time. So of all the scenarios, this is probably the best environmental benefit that we could see. And lastly, if we were just to migrate to IP-only radio services, we did see a reduction in the total energy, but we only saw half the capacity of energy saving that we saw in the previous scenario. And this is not quite as pronounced as previously because we've removed DAB from the system, which we showed in our baseline result to actually have the lowest footprint per hour. So that's kind of why we're seeing that there. And as we saw in the baseline results, also in our scenarios, we saw that standby power of radio sets and smart speakers were by far the biggest contributor to the energy result that we were seeing. So an interesting thing we thought we would test out would be if we were to remove standby power from the system, if standby power was set to 0 from 2021, what impact that could have on the total energy. And when we did that, what we saw was that we could actually see a 38% reduction in the total energy. And what this would mean in reality is that people remove their devices from their power source when not in use. And although this might be unfeasible in practice, what it does reveal to us is that any reductions in the standby power could have a significant impact on the total energy. And, that could be affected through audience behaviour, but that could also be affected through regulation of consumer electronic devices, as well as through manufacturers reducing the power consumption of their devices. So to summarise, from a sustainability perspective, we shouldn't be carrying on as business as usual, as all our scenarios showed energy saving potential. And of all of them, we saw that keeping on DAB and IP led to the largest energy saving by far. However, our results were highly dependent on which devices people switched to, therefore messaging around that would be really critical if we were to turn off certain platforms. And also lastly, it's really important to mention that the radio set and smart speaker standby power was very significant. Therefore, any avenues that we could explore to reduce that would be really critical. So that would be audiences, regulators and manufacturers. This research reveals the importance of taking a system-wide approach when considering the environmental impacts of services, products and technology. So thank you very much for watching. Please feel free to pop me over an email if you have any questions or wanted to discuss any of this further. We'd suggest you check out our paper, which is available on the BBC R&D website if you want to learn a little bit more. Thank you very much.